Now, the third protocol I want to talk about is ospf, that is Open Shortest Path First, and this is an algorithm that is used in linked state protocols like ospf and IS2IS. Now, IS2IS is quite simpler than ospf, but ospf and IS2IS, because they are standards, they are widely accepted. Although EIGRP is not a standard, it is Cisco proprietary, but most of other vendors also support EIGRP. But here, as a standard protocol, we have ospf, and that's a very complicated and, of course, very efficient protocol to work with. Now, ospf has some concepts. For example, ospf divides our networks into areas. And there is an area that's area 0, and that area is backbone area. Every other area has a connection to backbone area. And this connection can be a direct connection or provided with virtual links. And I'm going to show you some example of virtual links, of course. In different areas, we can, arrange our routers or different branches of our offices. I'm not going to talk about design concepts of ospf. I'm just talking about configuration of ospf in this CCNA Lab series. So first of all, I want to put every router in one area and see the database of ospf, and then I will split this topology into several areas and see the database there. So to do this, first of all, I need to remove the EIGRP configuration that I had previously. So I go to configuration mode, and now router EIGRP1 will remove EIGRP from my router. So I copy this command again, and I want to run this on other routers as well. I go to configuration terminal mode, and in router 3 as well, and router 4. Okay, now that we have removed our routing protocols, I want to add ospf. Now, to add ospf, we add this in global configuration using router ospf and then a process number. Now, this process number is a local value. That means it is locally prominent. It does not affect any other thing. Just it is used to define a process number, and every interface that is in this process number will work with this. And of course, it doesn't affect neighborship and nothing else than this. So I use number 1 for this, for example. And now that I have defined router ospf process, I can add again the interfaces in the same fashion that I added EIGRP interfaces to EIGRP process. And of course, ospf has a new way to add interfaces, and that's a command that you put it directly under interface configuration mode. Now, I use the old fashion first and then go to the new fashion. Some of switches, of course, do not support the new fashion way, but the network command is there, and it works exactly as the way that EIGRP network command works. So I add 10, 0, 12, 1, and again, I want to put this interface explicitly, so I add 0, 0, 0, 0, 0 to this, and now I need to specify which area this interface is going to work in. Now, as I told you, in my first configuration, I want to put every interface in area 0, so I put area 0 here. Now, the other interfaces are going to be there. For example, 13.1 is going to be there, and again, the loopback IP address, that is 150.111, is going to be in this area. Now, every interface is in this area. Let's see the result of show IP protocol command. And now you can see that I have routing for these networks. These networks are all connected to me. And of course, I have a gateway here, and this gateway will be the first loopback IP addresses that is on my system. And something else is very nice to mention, that's the router ID. And router ID is selected based on the loopback IP address that is working, the highest number of loopback IP address that is working, unless you add the router ID explicitly. And now I want to explicitly assign this value 150.111, so that anytime I add another interface, for example another loopback interface with a higher IP address, that would not affect my router ID and that would not affect my neighborship with other routers. So this is the value that other routers will take care of. Okay, now I have my configuration, I have my router ID defined, and I want to go to router 2 and define router ospf on these other routers. So I go define router ospf, for example 1, whatever number you enter, that's not a problem. I want to explicitly tell that 151.22 is my router ID. Now I add the networks to this 10.0.12.2. 0.0.0.0 is in area 0, and you can see the neighborship is coming up after a while because I have two neighboring interfaces that are in the same subnet. They use the same area, and now that they use the same area and other, of course, options that I'm not going to talk about, they create a neighborship, and now they know about each other. Now I add other segments to my routing process, and of course I want to add the loopback value here, and this would be in area 0 as well. Now I go to router 3 and start the same thing here, router ospf 1 router, and now I add router ID 151.33. Network is 10.0.13.3, and this should be in area 0. Now that I have put this here, I should see another neighborship coming up here, and that's working. And another network is 172.16.34.3, and this would be in area 0.1 again. And network 151.33 would be in area 0.2. So I have this configuration here on a router 3, and I go to router 4 to configure this router ospf 1, for example. Router ID is 151.4.4. Networks are added. 172.16.34.4 would be in area 0, and now I should see the neighborship coming up here. That's okay. And again, network 10.0.24.4 is in area 0, and another neighborship should be here. And now network 151.4.4 is in area 0. Now that I have every interface connected in my area 0, I want to see some routing table and another verification commands results. So I go to privilege mode to have a full feature of show commands here. I show IP route first, and you can see routes that are flagged with O, and these routes are ospf routes. So if I want to check the reachability to, for example, 150.133, you can see that this is reachable to me, and it's very nicely working. And now I want to see some other verification numbers for commands results. For example, I want to see show IP ospf interfaces in brief, and you can see that my interfaces are listed here. Their process ID, that means the process that these interfaces are working under, that the area that this interface is assigned to, And the type of network that, of course, this is not the type of network, this is the role that this specific interface has. And this DR means designated router, and it means I am designated router. Every other router that is in the same subnet with my interfaces should send its routing table, or should send its link state advertisement, that is LSAs, to me, so that I distribute it among the other. For example, in a network that I have several routers in the same subnets, I will do that. Here in my network, I have just point-to-point connections. I do not have several routers in the same subnet, so I do not need designated router configuration. Whenever I talk about frame relay configuration, I will tell you what this DR and BDR and other things means specifically. But here, this is not an important issue. Okay, now I can see that I have one neighbor here, and for path 00 again I have one neighbor, and you can see that this is again DR, and that's it. Okay, let's see the list of neighbors. Show IPOSPF neighbor will tell me which neighbor are here and what neighborships I have created. You can see that I am neighbor with 151.3.3, and this is the ID that I assigned to that router, and you can see that its role is backup designated router, that is BDR, and its address is 10.0.13.3. This is the address that I can reach to that neighbor, and the other neighbor is 2.2. Okay, so I have this. Let's check OSPF database first, and I want to change the areas in some of these interfaces next. Show IPOSPF database tells me about the different LSAs that are available in my network. LSA is link state advertisement, and a router sends these LSA to other routers to tell this router that I have these connected networks. For example, you can see this is advertising router. This is me, of course, but it doesn't matter. As this router, I tell other routers that I have this link available to me. Router 3, for example, tells me that it has a link available, and it can I can reach it through this, and this is the meaning of LSA type 1 or router LSA. And you can see that we have LSA type 2, that's network LSAs as well, and this is because our network has designated router, backup designated router, and other types of routers. So what does this mean? 151.1.1 or router 1 says that I have this link available, and you can reach it through me. Again, router 2 says that I have this link available, and you can reach it through me. And these are the meaning of LSA type 2. But other LSAs are available to me. So let's divide my network into different areas, and for that I want to use some shapes here in GNS3. I want to put router 1 and router 2 in area 0, and I want to add these interfaces, of course, to area 0. The other interface will go to other area, so I want to change the style and select the color here, for example, red, and this is area 0. I can add, of course, a note here, for example, type in here area 0. Now I add another rectangle here, and I will say that this router and this router, I want to put it up. Okay, now I change the style of this using another color, for example green, and now I want to send it back using lower 1 layer, and the link is there. I want to send it back too, so that I can see the link. Now this is area, for example, 1. I put a note beside this, area 1, or I should name it area 13 to recognize that this area is between router 1 and 3. And the number is not important. I want to just show you the difference between different areas. So this would go there. Another color, for example, the blue color will be added here. I want to send it back a little. And now I add another note here to show that this is area, for example, 24, to be able to recognize this. Okay. We have 3 different areas, and now I want to assign these interfaces to these areas. And of course, I will have another area here, and I want to show you what is the use of virtual links. So I put these interfaces of the 2 router into an area that is not connected directly to area 0. And this would be an issue that we can solve it using different okay. This is okay. And I send back step, and I name it area 34. Okay, now I have different areas. I have some type of area that is not directly connected to backbone, and I want to solve it using 2 different approaches. Okay, now I will go to configuration. Let's do our configuration here. First of all, I will put router 1's interfaces into area 0. I have fast 00 in area 0 already. R2, I have fast 00 in area 0 already too. And their loopback interfaces are in area 0, and that's okay. But I want to change the area of fast 01 to 13. So I go to router 1, I go to configuration, and go to router configuration using a router ospf 1, and I change the network. Network 10.0.13.1.0.0.0.0 will be in area 13. So I change the area, and as soon as I change the area, you can see that the neighborship is down, because now the 2 neighboring interfaces are not in the same area. And I can see these error messages that I'm going to fix this in a moment. I go to router 3, and here I change the network 1.10.0.13.3 to area 13. And as soon as I do this, the neighborship is coming up again, and it will work in a minute. Okay, now let's see the neighborships to show IP ospf neighbors, and I can see that router 1 is in two-way mode. Two-way mode says that I am creating the neighborship. I have not yet exchanged my database with router 1's database. For a moment I will be in this state, and after I exchange my database, I will go to fully adjacent mode. That means the full here. So I should wait for a second, and you can see now the adjacency is in full mode. Okay, now I want to change other interfaces here. I want to change the interfaces of router 3, is specifically the serial 01 interface, to area 34. So I change the network. What is the IP address? That is 172.16.34.3.0.0.0.0, and put it in area 34. Okay, now the neighborship is going down. Now I want to do the rest of configuration in the next section, so that this section is not getting too lengthy.